Okay, welcome back. Now that we've talked about what hyperbolas are, what all the things involved in them are, let's do some specific examples. Find the center, vertices, foci, and eccentricity of the hyperbola y plus 1 squared over 4 minus x minus 3 squared over 1/4 equals 1. Draw the axes and the asymptotes and use them to help you sketch the hyperbola itself. So notice this does have the kind of equation that gives us a hyperbola. You've got something squared over a number minus something squared over another number equals 1. Okay, first question, where would the center of this hyperbola be? The x-coordinate would have to be 3, and the y-coordinate would be -1. So the center is the point 3, -1. There it is. Is the transverse axis, the one that goes from one branch to the other, is that horizontal or vertical? Well, it's the y part that comes first in the subtraction. So the transverse axis is going to be going y-wards, vertically, up and down. Where are the vertices? They're going to be above and below the center, but how far above and below? Well, look at the number down here below the y squared part. The first number is a squared. A squared is 4, so a would be the square root of that, 2. So that tells us how far up and down to go to get to the vertices. One of them is 2 spaces up at 3, 1, and the other one is 2 spaces down at 3, -3. So at 3 for the x-coordinate, that doesn't change, and then -1 plus and minus 2 for the y-coordinates. So there they are, there's the vertices, and I've drawn in the transverse axis that connects them. What about the conjugate axis? It's going to be perpendicular to that, so it's going to go through the center, but horizontal. So b squared is the number down here in this denominator. B squared is 1/4, so b would be the square root of that, 1/2. So the conjugate axis would be, if you start at the center point and go 1/2 unit left and 1/2 unit right. 1/2 unit either way in the x direction. So that would take you from 2.5 -1 to 3.5 -1. Now, to use the axes to draw the asymptotes, we would draw a rectangle, a box around the axes, and then draw diagonal lines that pass through the corners of that box and cross in the center like this. So now we should have a pretty good idea where the hyperbola itself goes. It's going to stay between the asymptote lines. It's going to come down and change direction at the vertex and come back up. And then the other branch is going to come up and turn and come back down. Like that. What about the foci? Well, to know where those are, we need to know what c is. And c squared is equal to a squared plus b squared for a hyperbola. So here that means that c squared equals 4 plus 1/4. So that would be 16/4 plus 1/4, or 17/4. And if that's c squared, c would be the square root of that. The square root of 17 over 4, or the square root of 17 over the square root of 4, which is 2, and that's approximately 2.06. So here c was only a little bit bigger than a. And so the foci are only a little bit past the vertices. They're almost right on top of them, but they're really just a little bit past. So if you start at the center and just go up or down 2 spaces, you get to a vertex. If you start at the center and go up or down 2.06 spaces, you get to a focus. So the foci are at points where the x-coordinate is still 3 and the y-coordinate is -1 plus or minus that number c, which is the square root of 17 over 2. What about the eccentricity? Well, E equals c over a. That's true for either an ellipse or a hyperbola. We said that c was the square root of 17 over 2, and a was just 2. So that comes out to approximately 1.03. For any hyperbola, the eccentricity is going to be greater than 1. Here it's only a little bit greater than 1. Next example, write the equation for the hyperbola with foci 1, 1 and 113 and eccentricity E equals 2. So this should be enough information to figure out exactly what hyperbola we're dealing with. The center has to be halfway between the foci. So the point that would be halfway between 1, 1 and 113 would be 1, 7. Same x-coordinate, and then the y-coordinate is halfway between 1 and 13. You can find that by adding them together and dividing by 2. So like the average of 1 and 13 is 14 over 2 or 7. The foci are 6 units away from the center. One of them is 6 spaces below, and the other one is 6 spaces above. So C, which stands for the distance between the center and either one of the foci, is 6. And because the foci are above and below the center point, we know that the transverse axis is vertical. It's in the y direction. The other information we have is that the eccentricity is 2. We have the equation E equals c over a, and we know the numbers for c and e. So 2 equals 6 over a, and from that we can work out that a equals 3. And then we have the equation c squared equals a squared plus b squared. We have 2 of those numbers, so put in 6 for c and 3 for a, and we have 36 equals 9 plus b squared, so b squared equals 27. Then b would be the square root of 27, but when we write the equation, we're really just going to need to know the b squared. So here we go, y minus 7 squared over 9 minus x minus 1 squared over 27 equals 1. Notice how in general it has the kind of form that a hyperbola equation has. It involves subtraction. The y part comes first because the transverse axis is vertical. Since the center is the point 1, 7, we've got x minus 1 squared and we've got y minus 7 squared. A was 3, so a squared is 9. That goes down here. The a squared always comes first in a hyperbola. And b squared is 27, so that goes down here. And this is what that would look like. If you draw the graph of that equation, here is that hyperbola. Next example, find the center, vertices, foci, and eccentricity of the hyperbola 9x squared minus 4y squared minus 36x plus 8y equals 4. Draw the axes and the asymptotes and use them to help you sketch the hyperbola itself. Okay, the way this looks right now, it is not in that form that we would like it to be in, where we could see right away where the center point is and what the a squared and the b squared are and all that good stuff. So to wrestle it into that form, we're going to have to do some completing of the square. So this works a lot like one of the examples I did last time in the ellipse section. First, rearrange the terms so that the terms involving x are together and the terms involving y are together. Then from the terms that involve x, factor out the x squared coefficient, which gives you 9 times the quantity x squared minus 4x. And from the terms involving y, factor out the y squared coefficient, -4, which gives you -4 times y squared minus 2y. Notice we need a minus times a minus to get a plus. Now, inside each set of parentheses, we need to add in the number that completes the square, that makes that a perfect square. And the trick is, look at the coefficient on the x, take half of that and square it. So here, half of the -4 would be -2 squared is 4. Half of the -2 would be -1 squared is 1. So we're adding 4 here, we're adding 1 here, and what we really did was we added 4 inside the parentheses, so it was getting multiplied by 9. And we added 1 inside these parentheses, so it was getting multiplied by -4. So to keep everything balanced, we have to add the same thing to the other side, 9 times 4 and -4 times 1. So now this is 9 times x minus 2, the quantity squared, minus 4 times y minus 1, the quantity squared, equals 4 plus 36 minus 4, which is 36. Now there's one more step to get it the way we want, and that's to go from a 36 to a 1. So divide both sides of this equation by 36. 36 divided by 36 is 1, and then over here, the 9 over 36 reduces to a 4 in the denominator, minus the 4 over 36 reduces to a 9 in the denominator. Now that we have this equation, can you see the center is at the point 2, 1, the point where x is 2 and y is 1. A is 2. A squared is 4, so A is 2. The transverse axis is horizontal in the x direction because it's the x part that comes first. So the vertices are at 2 plus or minus 2, 1. That is, you start at the center point and go 2 spaces in the x direction. To the left gets you 0, 1. To the right gets you 4, 1. B squared is 9, so B is 3. That means the conjugate axis would be if you start at the center point and go up 3 and down 3. And C squared equals A squared plus B squared, 4 plus 9. So C would be the square root of that, the square root of 13, or approximately 3.6. So the foci are the points where if you start in the center and go that many spaces in the x direction, left or right, so 2 plus or minus the square root of 13, and then the y coordinate stays at 1. That puts you at about -1.61 and 5.61. And the eccentricity is c divided by a, so that's the square root of 13 over 2, which is approximately 1.80. So here is the center at 2, 1. The A is 2, so the transverse axis goes left and right 2 spaces either way. B was 3, so the conjugate axis went up and down 3 spaces either way. There's the box around the axes, those diagonal lines are the asymptotes, and then here is the hyperbola itself. When you have an equation all written out like that, how can you tell what kind of graph it is? Well, if the coefficients on x squared and y squared are the same as each other, you have a circle. Can you see which one of these is a circle? When one of them is 0, that is, you either are missing an x squared or you're missing a y squared, then you have a parabola. When they are the same sign, both positive or both negative, you have an ellipse, as long as they're not the same number, which would give you a circle. And if they are opposite signs, one positive and one negative, you have a hyperbola.